So, lecture 12, it's about ISO SI 7 layers, right? So, this from this lecture onwards, actually, we have 2 more lectures to complete. That is lecture 13 and 14. So, lecture 12 onwards, we are going to learn about ISO OSI 7 layers. But especially, we will be focusing for first 2 layers. That is layer number 1, physical layer, and layer number 2, data link layer. But before learn about physical and the data link layer, you should have an idea about what is this ISO SI network model. So the things that we discussed in the recently finished lecture, the bandwidth of the signal, we discussed about composite signals, Fourier analysis, bandwidth of the signal equation, Nyquist bandwidth theorem, as well as Shannon's capacity or Shannon's law. So these are the things that we discussed recently, finished lecture, that is lecture number 11. This new lecture is based on learning outcome 8, where we are going to study about physical layer, data link layer, and basic functionalities, features. Basically, you will learn a specification called RS-232 standard under physical layer. And also you try to identify what are the 7 layers available in ISO SI 7 layer networking model and TCP/IP network model. So that is learning outcome 8, right? So we have skipped learning outcome 7 in this lesson, right? Learning outcome 7 and 8 comes in the physical layer lecture, that is lecture 30, right? So this is the lecture 12, ISO SI 7 layers or network models. So this lesson is actually a bit of theories, right? Because we are going to have a discussion about the layer architecture. So we have to discuss so many theories and the concepts that we have seen from the 1970s onwards. And basically we try to identify their basic functionalities like encapsulation process. So no calculations will be involved in this lesson, right? Just a theory-based lesson. So this is where we are going to start it. Protocol layering. Now this ISO SI 7 layer, with the name of this network model, it says that ISO OSI 7 layer. 7 layers means there are 7 layers in this network model. Now there should be a reason to start with layers. Why we go for layered design, layered architecture, layering, right? Now if you take an onion is having several layers. I think if you have used Tor browser, the Tor browser also, the icon of the Tor browser is onion. Why we have several layers. So that layer design is something else, right? It's regarding security. It's something like regarding defenses. But this one will work with normal layers. So why we work with these layers? When you have very complex process to explain, if you break it into several steps, it would be very easy to understand. Now, if I start with multiplexing lecture first, it will be a very complex lecture. At the very beginning, if I start with multiplexing lecture, you don't know what are the basic points. What is a sine wave? If I start with the calculations, like multiplexing calculations, you don't have an idea about what is a sine wave, what is this analog signal, why we are using frequency, right? So then we have broken this all of these lessons into several steps. So before you learn modulation, you learn the basics of what are the basic characteristics of the sine wave, right? Before you learn the PCM, pulse code modulation, you have learned the basics. So gradually we increase the complexity. So when you have layered design, you can break this complex process into stages, different steps. So why do we build up this network model? Now we work with data communication concepts up to this lesson, right? Recently we finished lecture 11. So it was again a data communication concepts. Now from here onwards, we are going to work with networks. Now when you are working with data communication and computer networks, you might have a doubt. What are the things that actually we are learning from these lessons? Because we did some calculations that you have learned in physics at the very beginning. Then we did some calculations in the modulation, pulse code modulation, right? And multiplexing, transmission media. So are these things related to this networking? Actually, that is the base, right? So every network is built upon this transmission media, hardware components, combination of softwares, as well as protocols, rules. So all of these things we need to combine together to implement a network, right? So why do we do networking? The main reason to do networking. What is the main reason? Sharing resources, sharing hardware. That's the main resource. That's the main reason that you say. But actual reason is we need to have a communication process. We need to implement the communication process. Now in this scenario, you can see that there are some students in here. So even without microphone, you can hear my voice. So that's where we started from lecture 1. So when students are here, I don't need to use a microphone. So this microphone is for something else, right? So if you keep the microphone away, still you can hear my voice. So we are face to face. The communication process is very simple. The students who are in here, they have a very simple communication technique that you are facing each other. So we have two sections, lecturer and the students, two parties facing each other, face-to-face communication. So if you have questions, you're not going to forward it via the chat, right? You can ask the questions directly because I'm here, right? You can ask the questions. Either you can come over here, or when you are free, you can come and ask the questions because you are here. But the students who are connecting via the Zoom session, they have a very complex scenario. But actually, when you think about the basic scenario, you will feel like, okay, I'm doing the lecture. We have connected via an application called Zoom. And it is supporting us to transfer our voice signals as well as video. Video means these lecture slides are the changes of the lecture slides and all the things will be recorded. So all of these activities can be communicated via the network. But behind the scene, behind this communication process, the Zoom students and us, we have a very complex scenario behind the network communication process. So when you have face-to-face communication, it's a very simple thing. So when you want to establish a communication between another party, we should have at least one layer of communication. So how do you implement a one layer communication? There's a small scenario. Now we have two girls, two friends, Maria and Anne. So these two are two friends who are working together. So when they want to share ideas, when they like, with friends that you know that we have usual discussions, friendly discussions, right, or arguments, all the things. When you are having face-to-face communication, it's very easy, right? So during this class time, like at the very beginning, we saw that all of you are talking to each other, right? When you come inside the class also, everyone is very busy with the discussions. So we don't know what are the things that you are discussing, but anyway, you have direct communication, right? Face-to-face communication. Either something you are enjoying or something you argue, right? Anything. But it's face-to-face communication. It's a very simple process. But when we are connected with all of us during the lecture time, still we have face-to-face communication. But this is, you can see, it's not very simple this communication relationship is not quite simple as the relationship that you had with your friends, right? You can't send jokes, right? You can't exchange jokes with me, but there's no restrictions, right? I always welcome. If you have jokes, you can share it with me. So then everyone can have a very leisure time as well, right? Enjoy the lecture. But anyway, when you are like meeting the lectures, then we have some kind of a difference, right? We try to maintain this communication process as a formal way, right? You try to be quiet, right? When the lecturer is asking questions, you are sometimes you are answering, but sometimes you try to avoid answering, right? If you are not confident enough, right? So like this, we have some limitations. But in friends, between friends, you share your ideas very freely. But anyway, if it is a face-to-face communication, there's only one layer, right? So when you look at this picture, you can see these two girls are friends. So they have one layer of communication. What is this one layer? When one person is speaking, the other one is listening. Here you can see it very much compared to your friends, right? When I'm speaking, nobody is trying to speak. Unless you try to sometimes you tell something to your friends, but not in loud, right? You don't try to share things with me. But most of the time that you can see that somebody is talking, the other one is listening. But during friends, it's something else, right? You can see that when somebody is speaking, no one wants to hear, then they will try to over talk and try to ignore their discussions, right? So we have a different situation. But basically, if you have very formal friendships, now during a class, like in a class, we can't expect a formal friendship. But in an office environment, we can expect a formal friends, right? Formal friendship. Why we call it as formal friendship? Very formal, right? Now between our, like let's say that the employees who are in here, the lecturers, so you can see there are some age gaps. Some of us are in the same age range. Some of us, like we have elders as well as very differences with the lecturer panels as well. But it's an official contact. It's not friendly. Yeah, having friendly, but it's an official contact. It's a formal communication process. So we try to maintain that basic requirement. When someone is speaking, the others is listening, right? So then you have very simple communication process where you have only one way. So what is the basic thing that we try to apply here? Small rule. When one person is speaking, the other one is listening. Kind of respect, right? Try to grab the information. So that's the small rule that we try to apply. And the other one, common language. Now, when we are working in the office environment, usually we speak in Sinhala because all of us, mother tongue is Sinhala. Right? Now, during the class time, we use English as the language. But there are some students with different native languages, right? Basically, in our class, we have Sinhala and Tamil students. Even you are speaking either Sinhala or Tamil. Some of these Tamil students, I know that they can speak Sinhala. So we don't know Tamil, right? So I don't know Tamil, right? It's the actual scenario. So I don't speak Tamil, so I don't understand. But some things I can, some parts I can understand, right? In Tamil, like when you are speaking. But most of the time we can't speak Tamil. So we usually share your information in one language, either English. So if the student speaks in Sinhala, we used to speak with them in Sinhala, right? But during a formal discussion, still we use one language, that is English, like in lecture conditions. So it's very simple, right? We have very few set of rules. So these rules can apply when you have face-to-face direct communication. So that's what they experience. This Maria and Anne, they experience face-to-face communication, very simple communication. They are friends. So they can use same language, right? Very simple rules like listening to the other one when somebody is speaking, right? So communication between Maria and Anne takes place in one layer, face-to-face, in the same language. Communication media, transmission media. In this picture, the transmission media, you can see there is air. So in between us also we have air, that is the transmission medium. But with the online lectures, students, we have set of devices supposed to communication process, right? We have copper cables, microphones, speakers, everything is there with this network connection. So Zoom connection is a very complex scenario. So if you try to summarize the things that we have in this discussion, you can see the two girls, Maria and Diane, right? During this simple scenario also, we can see basic things, basic rules, what we identify as greeting each other. So I don't know whether you greet your friend when you see them in the morning with a good morning, right? Okay. So some of them, like maybe we are sharing that greetings as well. In a formal or official meetings, of course, we have these greetings with each other. Confine their vocabulary to the level of friendship. So that's what I mean. Confine their vocabulary to the level of friendship. So that means the terms that you use with your friends is different from the terms that you use with us. And we also have friends, and we also have friends in the office. But the terms that we are using for their discussions, it's totally different, right? The way that we talk to somebody who is a senior lecturer, it's different from the way that we talk with the same colleagues, right? Same age colleagues. Listening to the other party when they are speaking. So that's the most important thing. With a formal discussion, you have to listen to the other one, especially during meetings. Now in this classroom, you can see when I'm speaking, you try to speak, right? You try to share your ideas with your friends, but still the volume is very low, right? Proper acknowledgements or confirmation. So that's very compulsory, like in a formal meeting or either in a friendly meeting, we should have the confirmations or proper acknowledgements. Now, this is something that we can see as a very shortage in our basic communication, right? When I ask you a question, it's very difficult to get feedback, right? Especially the answers or the confirmations, whether you have understand this lesson or not. It's really difficult to get either yes or no, right? So if it is not clear enough, you have the freedom to say that it's not clear. You have to explain it again, right? So we don't get that confirmation from the students, but usually during official meetings, either formal meetings or informal, we have to share your idea as well as the confirmation whether this point is clear to you or not. So during network communication, it's very compulsory. Now, some of you have done file transfer in lab session. So I told you to use certain commands to see the connectivity of each and every PCs. So if you have checked the connectivity, you have seen that replies comes from the other side as well. Right? When you send a data packet to the other machine, usually from that machine sends replies. So it's very compulsory requirement in networking. But in usual communication also, it's a compulsory thing as a rule. Agreed upon speed and timing of delivery. So you should have a proper speed of delivering your message. Otherwise, it's not clear enough. As well as proper timing, right? So where you have punctuation, you should have a comma or you shouldn't have a question mark, right? So when you're questioning, it should be a like full stop, right? You know, when you're writing the things also, we have these punctuation marks, commas, full stop, as well as questions. So we should have proper timing as well as the speed. Common language and grammar, it's compulsory. So when you're with your friends, so most of the time we know that we use one common language. But during official meetings and official relationships, sometimes we use either English or kind of whatever the language that preferred by the organization. So between these two friends also, they are sharing these things. So these things comes as rules. So why do we need to maintain rules in communication? Otherwise it will be a mess, right? So we should have like either, especially with official relationships, you should have these basic rules, even though it's a face-to-face communication. You can make it complex. How do you make this communication process into a complex process? How do we convert a face-to-face communication into a complex process? There you have more layers than this. Now we had only one layer. Right? How do you make it into a complex level? With the rules, actually, we can't make it complex because these are the basic rules that you have between normal communication. But you can increase the number of rules. That's possible. It's based on the medium that you are using. How do you make it more complex? Let's say that these two girls are in two different locations. Right? Not in the same office. They are in two different offices or two branches. Then they have to use either telephone network. So taking a telephone call, do you think that it's a complex process? What do you think? Okay, we'll convert this, the current scenario of doing the lecture. Now, if the number of students are too large and if you can't hear my voice, so then I have to use a microphone. And I need to use these speakers. Is it going to be a complex communication technique? Yes, right? Because microphone should capture my voice signals. You need to do conversion of the voice signals, analog signals. This microphone is connected by copper cables, right? We need to do some conversions and transfer it to the speakers. Right? It's a complex process. So we can make this communication into a complex process if they live in two different states or two different countries or in a distance. So that's what this diagram shows you. You have many number of layers. It's because now they are not in the same office, right? So what they say, assume Maria and Anne do their conversation using regular mail through the post office. So they haven't, they don't use telephones to do the communication. Like it's, if you have some official documentations to share, then you should have a way to share it. So they are going to use post mail to send their messages. And they want to share their ideas securely. That's a requirement. So that's kind of a requirement that they're expecting. So they agree on an encryption or decryption technique. So encryption and decryption techniques actually comes from security. Right? Encryption means you are converting simple message into a unreadable message. Encryption. So when you convert it into unreadable format, when you get the message, again you have to convert it back to the normal message, right? Readable format. So that is the decryption process, right? So we have two new terms, encryption and decryption. Encryption means plain text or readable message converts into a ciphertext. Right? This is readable. This is actually unreadable, or it's a scrambled message. So that is encryption. So when the other one receives this ciphertext, the scrambled message, you have to reverse it back to the readable format. Then only you can read it. So that's what we call as decryption. So converting ciphertext back to plain text. So that is decryption. So why do they do that? Because they want a secure communication method. They want to have a secure communication process. So that's why they are using this encryption and decryption process. Otherwise, it's not compulsory, right? But as you can see, this communication between Maria and Anne has become a very complex process. It's because now they are not living in the same area or same office. So they are working in two different locations. And this document should be sent or transferred via postmail. It's not email, it's a postmail. So what they do is, one of them will record the message, right? So let's say that Maria is the one who is initiating the communication. She is going to record this message and convert this plain text into a ciphertext using the encryption process. So the first process is, first layer, they either listen or record the message, right? So this one is talking, that means the recording of the message. Converting it into a encrypted format or ciphertext format means that is another layer. Then ciphertext message is packed into an envelope, write the recipient's address information and send it by the postmail, right? So you can see the layer number 3, sending mail or receiving mail. Sorry, layer number 1, right? Layer number 1 is send mail or receive mail. So here, ciphertext will be packed and send it via mail post. So when the recipient receives this, we start from this process of taking the message from the postmail, unpack them, and we get the ciphertext. Ciphertext, we can't read it. It's a scrambled message. You have to convert it into a readable format. That's the plain text. So converting the readable format, it's the second layer. Then transfer it to the Anne. So Anne will get the readable message. So she can either listen. If it is a recorded message, you can listen. Or if it is a printed one, you can read it. So that's the basic communication method that we have followed. We can add all of them together into one single process. But there's a reason to break these steps into 3 different layers. Now, when you consider this basic communication, you can see they want to send a very simple document or either message. But they want to make this transmission or communication process into a secure format. So they have a new requirement. So if you try to combine all of these things together and consider as one single layer, if there's a problem in one of these layers like encrypt and decrypt layer, it will be a problem for the whole process. You can't handle it individually, right? Let's say that we are using a robot to do all of these activities. Robot is listening to our message, converting message into an encrypted message or ciphertext, and they will either record it, the scrambled message can be recorded into a CD or something like that, and make the package and send it to the postman. So if Robo is doing all of these things, if you don't break these activities into sections, if one of these activities is not working, how do you handle the problem? It's a very difficult thing because you have to either buy a totally new robot with all the functionalities, or else you should find a way to modify whatever the part which is not working, right? So let's say that robot will record the message, but due to a problem in the conversion of encryption and decryption process, if the robot can't do that, then it's a problem. So then if you want to repair it, if you take all of these activities as one unit, then it's hard to repair. You need to buy a new robot to do the recording, prepare the ciphertext, and transferring or the packaging, all of these things, right? So why we divide it into several layers is to reduce the complexity of this communication. Now, simply you can see it's a very complex communication, right? So you can see that with the layers, you will feel like with the layers we have made it into a complex level. That's what you can see. But when you consider the actual scenario in networking, if you don't have these layers, it's a very difficult thing to handle, right? So in the next slide, we have all of these explanations. So what it says, assume that Maria sends the first letter to Anne. Now the things that I have explained with the diagram, it's explained in here. So Maria is the one who is initiating the message. The layer 3 machine listens to what Maria says and creates the plain text. That is a readable message. So there's a machine. So they are using machines or robots to do all of these things. So she is recording her message using one particular machine. And the same machine will do the second layer. This machine will encrypt this plain text message and convert it into an unreadable format or ciphertext. Then the layer 1 robot takes the ciphertext, puts it in an envelope at the sender and the receiver's address and mail it. So either they are going to record it into a CD, right? Then make the package and put the senders and the receiver's addresses and send it to the mail, right? Post mail. So from the AND side, who is the recipient, she will take this message from the layer 1 onwards, right? The first thing is they have to unpack all of these things. So layer 1 machine will pick up this letter from the AND's mailbox. And first thing is you have to recognize who is the recipient. So that's why we place an address. Now in a letter, in a usual postmail letters, we know that we have a recipient's address. Even though we don't have sender's address, most of the time, you know that every letter we should have recipient's address. So recipient's address will give some idea of who is the receiver. So in this first layer machine, it will read the message, read the recipient's address and identify who is the receiver. So recognizing the letter from Maria by the sender's address. So if you have sender's address, you can recognize who is the sender as well. So from machine 1, it will send to layer 2 machine. Why we send it to a different machine? Because we want to do conversion. Now we don't have one single robot, we have 3 different robots, right? One is taking the letter from the postmail, read the addresses and direct it into the second machine. So they will do the decryption. Take the ciphertext, convert it into the plain text. The third layer machine takes the plain text and reads it as though Maria is speaking. So the third layer machine will read the message and the other one, the AND can listen to the message because it was a recording, right? So you can see we have used 3 different machines instead of using one single robot. So if you have any failures in one of these machines, you can easily fix it. You can easily replace it. right? Now, when you have, like in our cases, you know that we have printers. Now, times back we had only printer, you can print only printing. Now, what we can see? We have printing, photocopy, scanning, even the latest printers, they can staple it. Everything is there, right? So you don't need to staple it. But if one of these components is not working, what will happen? You have to repair. But the thing is, these things can be repaired separately. That's the advantage, because we know that we should have some separations, right? It's not one combined device. If the scanning part is not working, they will repair it separately. It's not going to affect for the others. But in case if the machine process is just one process where you do all of these things together, so then you can see that repairing or troubleshooting will be a difficult. Even the understanding of this complex communication would be a difficult, right? So that's why we break them into several layers. Now, even with network communication, now here you can see the network communication via Zoom application. We have an application. Zoom is the application. And my voice signals, all these videos, these slides, everything will be shared via that application, right? Video and audio will be shared with the other students. Even when you are using chat, your WhatsApp, your Facebook, everything, for Facebook Live, whatever the communication techniques, all of these things behind the scene is a very complex communication. So you don't see the addresses actually. Now, when you are sending an email, what we can see is just the sender's email address. That's what you feel. So you feel, okay, the recipient will read it. But actually, behind the scene, this message will be converted, will be transferred binary values to the destination, right? Binary values will be converted into a signal. That's how we transfer it via the transmission media. So see, it's a very complex activity, right? So that's why we have protocol layering. So protocol layering enables us to divide a complex task into a several smaller and simpler tasks. So we can divide it into very simple activities. Now, what is this term protocol means? The term protocol means actually the rules. And we'll come to rules and see. According to the previous example, though we could have used only one machine to do the job of all three machines. To apply updates to the encryption or decryption process, we need to change the whole machine, right? So when you're updating these operating systems, you can update it separately from the other things. When you're updating the applications that we are using in our computers, we can update it independently. It's because we have these layers designed in these systems. Otherwise, when you update the operating system, you have to buy a new computer. Right? You don't need to buy a new computer. You can put a new, like this one is using Windows 7, this machine, but you can update this same machine to Windows 11. That's possible. You don't need to buy a new computer. Sometimes you have to update the RAM cards, all of these things, but if you have proper capacity, you can do the updates. So when communication is simple, we may need only one simple protocol. When communication is complex, we may need to divide the task between different layers. In case we need a protocol at each layer or protocol layer. So still we need to identify what is this protocol problem. When you make the communication process more and more complex, you need separate rules to handle all these things. Now, when you have face-to-face communication process, we had very simple things like listening to the other one, greetings, using common language, right? And having, like, if you are having a formal discussion, having proper behavior or the speed of delivery, all of these things were applied. Confirmation, acknowledgement, these things were applied. But when we had the complex process with 3 layers, you can see the decryption was there, encryption was there, So how do you do these conversions? We need to have some kind of a rule. So if the encryption of the message is not readable by the other side, what will happen? You can't decrypt it. Now, if I send you something unreadable, I know what is the key and I know how to convert it. But I'm not going to share how to convert it with you. If I just give you some message. So then if you don't know how to convert it, if you don't know what is the theory behind this, if you don't know what is the rule behind this, you can't read the unreadable message. Same for this situation, right? If the encryption mechanism used in layer 2 is not known by this layer 2 device, it would be useless, right? Because and can't decrypt the message. So there should be a common rule in between layer 2. And when you are sending this message by the post, there should be a common rule. You have to put the sender's address. You have to put the recipient's address. Now, usually in our informal letters, we never write the sender's address. But in a registered letter, I don't know whether you have sent a registered letter, but if you have received registered letters from different universities or somewhere like that, you have the recipient's address. On the other side, you have the sender's address. Right? Both should be there. Okay. So like this, we have very simple rules for each and every layer to manage it properly. Right? That's the main reason. The network is a combination of hardware, software that sends data from one location to another. So basically, in a network, it's not just hardware and software actually. We have transmission media, right? Transmission media, either wired media, copper cables, fiber, or wireless transmission media. And also we have protocols. Now we have learned we have something called protocols. We should have some kind of rules. The difficulty in dealing with network communications is that it is a very complex process. If we look only at network communication as a whole, we can see it's a very complex process. Now, behind this network transmission, like sending a simple email, actually you put only the sender's email address and you put subject and the content of the email. It's very simple to just one click away. You just send a message with attachments or without attachments. But when you send that message, actually there are many number of protocols involved with, many number of rules applies with. The sender's address is not the actual address that we are using to send this message, right? Because we need to find out what is the exact destination. We are using IP addresses, we are using MAC addresses. We have discussed about these terms before. MAC address, it's the way that we identify in our machines. IP addresses, from a network, you can identify your working domain, right? So likewise, we have several ways to identify. Even if you consider a message email, we can't send the whole email at once. Actually, when you do the data transmission, we are dividing them into small pieces. Sometimes the subject part is in one message. Body of the email, the content, the very first sentence is in one particular package. So likewise, we have to divide it into small pieces. But at the destination point, we are sending all of these things, but we can't see that. We will see the complete message. We don't see all of these differences. Within microseconds time period, nanoseconds time period, we can see the messages. So we don't feel what's behind this situation, right? So that's what we are trying to identify, this layer design. So you need to learn the theory of how networks communicate before you design, build and maintain networks. So when you are working as network administrators, if you are willing to be a network administrator or engineer in future, definitely you should know what are the protocols that you have to work with and how do you divide your network communication into layers. The IT industry uses layered models to describe the complex process of network communication. So this is not the only place that we use layered models. I'm not good in software engineering, but with related to networking and security, this is not the only model that we are using. As I told you that with the Tor browser, I told you that its icon is the onion. In an onion, we have several layers, right? So where that design, what we are trying to expose during this, like in security terms, we want to say that we have many defenses. Now, in the current situation, what they do is they are making several defenses, right, to protect themselves from the protesters, right? So they make defenses. They are placing barriers. They have policemen, right, or the tri forces or the army, right? Likewise, they have different defenses. So what they place is the defenses. Defenses means it's like a layer. Barrier, the small barrier that you put is the first layer. Then you have people to protect them. Likewise, we have several layers. So in here also, we try to make it complex in the network communication. Protocols for specific functions in the process are grouped by purpose into well-defined layers. In a layered communication process, each layer performs a specific task. These layers interact with the layer above and below them only. Now, when you have layers designs, each and every layer is enhanced with protocols. Each and every layer we have rules. Now, with face-to-face communication, we had few rules, right? But when you are working with the network layer, with the design, I'll tell you, with the layer name also we have some protocols, and we are categorizing some protocols or rules under each and every layer. And each and every layer performs specific activities. They have, like when you are working with the physical layer, when we do the physical layer lecture, if you realize it, we are listing down certain functionalities. This physical layer can do these things. Physical layer will do these things. Data link layer can do these things. Likewise, we specify these are the activities that they can do. And when you do the communication, actually they can't communicate with the higher layers. Let's say that physical layer will not be able to communicate with the seventh layer directly. You always have to communicate with the layer upper or layer below, right? So it's like we won't be able to talk to president directly, right? That's the problem, right? So then we have to pass several layers, right? So that's what we are doing, right? That's what the people are doing. So likewise, you won't be able to communicate with the seventh layer. The layer 1 will not be directly contacting the seventh layer. They will contacting the layer 2 first. Layer 2 can contact layer 1 and layer 3. Right? So they can communicate with immediate upper and below layers. In data communication and networking, a protocol defines the rules that both sender and receiver and all intermediate devices need to follow to be able to communicate effectively. So there we have the definition for protocols. Right? Protocols means the rules that govern the communication. Right? So in basic face-to-face communication also we had few rules. That's called the protocol. Right? So what are the benefits of doing these layered models? Benefits of following layered models. So there are nearly 7 benefits. The first one, it says defines common terms that describe the network functions to those working in the industry and allows great understanding and cooperation. Now what it says? We have very common terms in network. So when you are graduating from us and working in the industry, you will use the same terms. And even the students comes from Moratu or Colombo, they will use the same terms. Right? So if you don't have that standard, we have different terms. Segments the process to allow technologies performing one function to evolve independently of technologies performing other functions. For example, advancing technologies of wireless media is not dependent on advances in routers. So when you're updating the features of one of these layers, you can do it independently because they are going to communicate with immediate and below and immediate upper layers, and it won't affect to the upper layers and the below layers. So you can independently implement technologies or improve the technologies. Fosters competition because products from different vendors can work together. So that's the most important thing out of all of these layered architectures. Fosters competition means it will increase the competition between vendors. Otherwise, what will happen is we have to buy all of these devices from one vendor, right? So we can buy computers from either HP, or we can buy Lenovo laptops, or we can go for a Dell computer. We can choose any product. Even with networking devices, we have the same category. With networking devices, we have different manufacturers, Cisco, Netgear, like this, we have different manufacturers. So Cisco is very famous because we know that they are conducting examinations. They have professional certifications like DCCN. So it's a very famous company. So if you decide to buy only Cisco devices, you have to spend more money. But you can do the same activities with other devices, other branded devices like TP-Link or whatever the other brands. Now, if you take your Wi-Fi routers, home Wi-Fi routers, you have different Wi-Fi routers, right? Some of you may have Huawei Wi-Fi routers, some of you may are using ProLink, TP-Links, ZTE, like this, we have different Wi-Fi routers. Otherwise, the SETI or whatever the dialog, they have to provide routers from one vendor. So we can avoid that when you have layered design, because this implementation of these networking devices and these hardware components are independent. It's because of these layers. Provides a common language to describe networking functions and capabilities. So as I told you in the very beginning, we have common language. So even with basic communication, we have one common language to express our ideas. Assist in protocol design, because protocols that operate at a specific layer have defined information that they act upon and a defined interface to the layers above and below. So we are explaining what is the protocol design that we are using with each and every layer. Protocols related to each and every layer will explain you what are the functionalities that they can complete with. And also we can do troubleshooting. It will help us to do proper troubleshooting. As I told you, if you want to update any of these devices capacities, you can update it without any problem. Break down the complex total network communication system into series of layers. So that's for the understanding. So if you try to learn all of these things together, it will not be easy, right? The conversion, it's a very complex thing. So during our lectures also, we are not going to learn everything, because in the second year lectures like TCP/IP lecture series also, you will learn these same networking models, and you will learn what are the actual functionalities of every layer in second year content. But during this content, we are learning only first two layers. Layer 3 onwards, you will learn in the second year, right? So there are functionalities, why we are converting, why we do formatting, what we have to think about, like compressing these messages, formatting, making a session. Like this, we are dividing all of these things into separate layers. So layers are like the shelves in a for organizing similar protocols and functions, not inflexible rules. So it's like you're organizing your bookstore with several shelves. To understand how a particular technology fits in, we can use these layer designs, right? So you can divide your complex communication process into small pieces. So the common model that we discuss is the OSI model. So that's why the lesson starts with ISO OSI 7-layer design, right? But that's not the only layer design network model that we have, right? We have TCP/IP model as well. So what are the models? We have two models. Layer designs, we have two models. First model is protocol model, and the other model is reference model. So we are going to work with reference model because protocol model explains a lot of protocols, right? It will actually list down what are the main protocols. So when they introduced this layered architectures in 1970s, right? So both the protocol model and the reference models, they introduced during 1970s. A protocol model provides a model that closely matches the structure of a particular protocol suite. So in protocol model, we have very few layers. Actually, we have only 4 layers. So in this 4-layer design, we are trying to group all the rules. We have set of protocols or rules that we are using. So these things will be grouped into 4 layers. A reference model provides a common reference for maintaining consistency within all types of network protocols and services. So in reference model, the main purpose is to identify what is the actual way of doing the communication. It's like you are trying to identify the communication process. There we don't worry about the protocols. We need to know how this communication process will work. Like let's say you want to send a message to your friend. Let's say you type something like, "Hi, how are you?" So this message is containing set of characters, and actually behind the message you have binary values. So how do you pass these binary values? How do you generate these binary values? So that's what we have to think. In the reference model, it will explain to you how do we type, like when you are using WhatsApp or whatever the message, let's say Zoom chat typing, chat messaging. So then you are typing something, asking some questions from me, right? So you type some messages. So Zoom is the application. So from the Zoom application up to the network transmission, how do you generate it? We can't transmit the message as it is. You have to convert this message to a signal. How do you convert your message, "Hi, how are you" message into a signal? That's the complex process. That's the communication process. So that's what we explain with reference model. With protocol models, we will try to see how this network is actually implemented in terms of protocols. So when you are working in the industry, you have to configure these protocols, right? You will worry about the protocols. Actual communication process will not be considered in that. You will work with this protocol model. So the comparison between these two, a simple comparison is that the TCP/IP model is a protocol model because it describes the function that occur at each layer of protocols within the TCP/IP protocol suite. So protocol model best example is TCP/IP protocol model or TCP/IP protocol suite. Describes the communication process in terms of TCP/IP protocol suite and the way it functions. So actually in TCP/IP protocol model, we try to recognize what are the required protocols to smoothly run the communication process. But when you are considering the reference model, the best example that we have is ISO OSI 7 layers. So there are 7 layers. It's a very complex thing. So what is this OSI stands for? Open Systems Interconnection. That's the actual name of OSI. This describes the entire communication process in detail. So OSI model explains how data will be converted from the message level to a binary format. Right? So that's what we try to recognize from the reference model. The reference model is not intended to be an implementation specification or to provide a sufficient level of detail to define precisely the services of the network architecture. So in reference models, what we are focusing is how this entire communication works, not how to implement it. Right? We don't consider what are the protocols to implement these things. So these are the two diagrams of both models, right? So on my right hand side, you can see the protocol model example. This is the protocol model, TCP/IP protocol stack or TCP/IP protocol model. We have different names, right? Either model, stack, or suite, right? All of these things explains you the protocol model. And OSI 7 layers, this is the reference model. Now, when you read carefully, you can see some of these terms are similar, right? In OSI model, you have application layer, but TCP/IP protocol stack or suite, you have an application layer. Same name is used, transport layer, same name is there. But actually, how do we analyze these two models? How do we compare them in here? We compare or we combine the activities that we can done by application, session, and presentation and session layers together. We consider in a TCP/IP protocol stack as the application layer. The functionalities that we consider on the transport layer will explain via the transport layer protocols. The network layer has a different name in here. It's called internet layer in TCP/IP stack. And their functionalities, the functionalities that we explain on the network layer will be enhanced via the protocols listed on the internet layer. And the functionalities which comes on the data link layer and physical layer will be managed by the protocols listed on the network access layer. So that is the meaning of this, right? So if I ask you what is the difference between these two models, never write OSI model is having 7 layers, TCP/IP stack is having 4 layers. That's not the actual difference. So in this explanation, the difference is there. You can read it and recognize what is the difference. So in OSI model, as I told you, it will explain you the entire communication process. But TCP/IP protocol model or TCP/IP stack, if you consider how do you implement this communication process in an actual network. There you have to have an understanding of the protocols that we have to use. So you have to remember the correct order of these 7 layers, right? And the correct order of this TCP/IP protocol stack as well. So actually the layer 1 starts from the bottom. That's the special thing in here. In the communication diagrams of Maria and Anne, we had the label of layers, right? Always the bottom layer was layer number 1. Then we have layer 3, and the layer which is close to the Anne and Maria was the layer 3. So this one is also numbering in the same order. So this is layer number 1 of the TCP/IP model. This is layer number 2, 3, and 4. Especially with the OSI model, we have this. This is 7, 6, 5, 4, 3, 2, 1. So during our lectures, lecture 13 and 14 is based on these two, right? Physical layer functionalities and data link layer functionalities. So how do you remember this? You have to remember it in the correct order, right? So if I ask you to write the state, what are the 7 layers in the OSI model, you have to either write it like layer number 1, physical layer, number 2, data link layer, number 3, network layer, or you have to draw this diagram. And not the complete one. Actually, you can draw this diagram in this way, right? Okay. Either you can, like, this is not required, layer 1, layer 7, but it's not required. But if you draw the diagram, this is the way that you have to draw it, right? So then you have application at the top, but actually, when you're numbering it, numbering starts from the bottom. So it has actually a bottom-up approach. So you can easily remember this is in a small phrase like please do not throw the sausage pizza away, right? Please do not throw a sausage pizza away, right? So when you write the layered design, don't write those terms. Actually, we are using those terms to identify the first letter of each and every layer, right? So please, we'll start from physical. Please do not throw a sausage pizza away. But when you have the practice, actually you don't have any difficulties in remembering now. Like when you, if I consider my situation, when I was a student, I also used that term, but now I don't need it, right? So this is the model that we are going to discuss further, right? OSI model. This was introduced by ISO organization. Now, when you read the acronym of this ISO, if you expand the meaning, actually it tells you International Organization for Standardization. That's the correct way of writing the name of ISO organization, but for easy references, they have changed the name, the acronym have changed in as ISO, right? So in 1977, they introduced this OSI model by a committee called OSI. So OSI stands for Open System Interconnection. So this ISO organization, I think you have heard about ISO organization. They are providing many standardizations, not only in this networking, even related to other things like quality assurance, security, and risk management. All of these areas, they are covering with different standardizations. So this is just one standardization that they introduced related to networking. So this was established by the subcommittee called Open Systems Interconnection, known as OSI. So that's why they label this reference model as OSI model. So why do they implement this? In the early networks, we had networks maintained by organization itself. Like IBM, they had their own computers, they had their own technologies, they used their own networking devices. So when you want to communicate with other organizations, there was a difficulty. Because they have their own way of communicating. They are using proprietary protocols. Now we have a new term called proprietary. Proprietary. What is proprietary? Proprietary. Proprietary. Right? Proprietary means unique only for particular technology, right? Now, for an example, if you take one manufacturer like Cisco, let's say that Cisco, we have Cisco networking devices. And also they have implemented some protocols. If these protocols are working only for Cisco devices, it's a proprietary design. Right? It's a proprietary design. Even with Microsoft products, also we have the same scenario. Some of these devices, some of these tools, these things can be proprietary, can be used only with the manufacturer's products. So early networks, it was proprietary because that organization is making their own devices. They have their own networking communication methods and own protocols. So it was so proprietary. So when you want to communicate with other organization networks, you have to use some conversion technologies. So instead of using these conversion technologies, they wanted to establish an interoperability between all the communication systems. So maintaining the interoperability between all the systems, they focus on this OSI model, right? So this subcommittee was developed to introduce interoperability between multi-vendor systems. The subcommittee developed the Open Systems Interconnection Preference Model. So this was commonly known as ISO OSI 7 layers or OSI model, OSI stack, right? Likewise, we can label it with different names. So this is where we stopped before the break. We discussed about the OSI model and we had 7 layers in this model, starting from the physical layer. So that was the layer number 1. And layer number 7 is the application layer. So from the physical layer to the application layer, we have to know how data will be transferred and how data will be manipulated in order to send it by the transmission medium. Now, when you are using a PC inside this computer, actually we can find all 7 layers, right? So in one of your, like, let's say that you are communicating with 2 users, we have application layer. So that's the application, can be the web browser that we are using, or maybe an application like we use in Zoom application. It's an application. Zoom is an application, desktop application we have, as well as we can use the web application. So likewise, we have an application and data will be presented either in audio or video format. So likewise, we have all 7 layers and data will send from the application layer towards the physical layer. So when you see the physical layer, examine the physical layer, you will see all of this information will be represented as ones and zeros. And before you send it to the transmission media, you have to convert these ones and zeros, this binary pattern, into a signal, electromagnetic wave. So when the recipient or the receiver receives these messages, these binary messages, you have to convert them back to the way that you can read it. Because as humans, we know that we can't read the signal, right? We can't read the information where we have received as an analog signal or as a digital signal. You have to convert it into a binary format first. Then again, from the binary format also, you have to convert them into a format where you can read it. So until that, you have to send these information through these 7 layers from the physical layer onwards up to this application layer. So using the application, you can access that information. So if I take the example that we are doing, example that from the current scenario. So we have an online lecture now, right? So I'm conducting this lecture via the Zoom application. So application layer facility is the Zoom. So this data will be represented as audio and video, and we have generated a session. So then other than that, we have a lot of data which is transmitted as segments, and the ones who are connecting in this application, they will connect via several IP addresses, and I also have an IP address. So like this, we have certain information along with some control information like IP addresses. And finally, when you consider this transmission media, we are sending all of these binary values in using the signals, right? Using a electromagnetic wave. So this electromagnetic wave will be received by your computer. That's the recipient. So your computers, the student's computer will be the recipient. So it will receive the signals. The signals will be converted back to the binary format and send it upwards till the application. So you won't see the binary data. Actually, you will see all the information as a audio and video files via the Zoom application, right? So that's what we are going to study with the encapsulation and decapsulation process. So that's the latter part of this lesson. So there are a few terms that you have to get familiar with this protocol, data units and encapsulation process. So before I will explain what is the term meant as encapsulation. So then we'll see what are the terms, what are the statements given in the slide, in this slide, right? So we'll try to understand the encapsulation process first. The process of adding control information as it passes through the layered model is called encapsulation. So we are adding some control information to our message. Now, when you send a message like hi or how are you, the message is just what you see is the message that you type as hi, how are you. And let's say that the recipient, the receivers, they also will see the same message, hi, how are you, right? But when you consider this behind the scene, as I told you in the before the break as well, it's behind the scene. It's not just the text that you are typing via chat application. We have so many information related to IP addresses, recipient's IP addresses, source or the sender's IP addresses, as well as MAC address information. Like this, we have so many information attached or connected to our information. So this information will represent as the control information. So this control information will be added to our data or added to the message that we are passing via the OSI model, right? So we'll see how it works with the diagram. Now, this is the diagram that I'm going to use, right? So I'll come back to the slides, previous slides, right? Now, let's say that I'm sending an email. Now, when I explained the passing of emails before the break, I told you that we just type the senders and we just type the receiver's email address, right? So sender's email address, of course, you can see by the recipient. Recipient can leave the sender's email address, but other than that, you have to type the text, the body of the email, as well as the subject. There should be a subject for an email and receiver's email address. So that's what you are typing, right? So that's what you are entering into your email. So these things will be represented as the data and they are in the readable format. You can read it, right? But actually, when you pass them towards the physical layer, you have to divide it into small portions because this email address, the topic or the subject of the email, the body of the email, all these things will contain lot of data, lot of binary values. So when you convert all of these things, you can't send the whole data at once, right? So email will be broken into small portions, right? Which is convenient for the transmission media as well as whatever the technology that we are using. So via the application layer, it will divide it into small portions of data. right? So that will be recognized as data portions or data. So application layer will forward this information by adding some control information to this data portion. So actually, when you consider this encapsulation process, not only the application layer, the below the application layer, we have presentation layer, session layer. So these two layers are also adding some information regarding the process that they do, regarding the functionalities that they handle. Now, for an example, the application layer, we have all the application softwares listed under this layer. Now, for an example, if you are browsing the internet, you are using web browser, right? If you want to access Google, how do you do that? You are using web browser. So likewise, we have set up application. Now, if you take Zoom, Zoom is an application, right? So the data format that they handle can be either text format, or maybe it can be an audio file, or it can be a video file, right? Likewise, it will be handled by the presentation layer. And via the sessions, we have originate a session to communicate with the other party. So that's what we do in the first top layers, right? Application, presentation, and the session layer. So in brief, right? I gave you some instructions in brief. So these three layers will consider all of this information in small portions as data portions or data, right? So these three layers are adding some control information regarding the application that they are working and regarding the data format that they are handling, right? Now, for an example, presentation layer, if the data format is in zip file or compressed, or maybe you will have to handle the encryption. So as we discussed with the secure data transmission, Maria and Anne was using encryption mechanism and decryption mechanism. So if you want to do that, you need to handle them by the presentation layer. So presentation layer is also adding some information regarding what they have done. Session layer is also adding some information regarding the activities or regarding the functionalities that they have completed, right? So from each and every layer, like application, presentation, and session layers, adding some control information to this data packets. So individual data packet, now you can see this email data is divided into three data packets, data portions. So individual data portion will be attached with all the control information, right? Application layer is adding what is the application that they are using, application software they are using. Presentation layer will add information regarding the data compression, data formats, encryption or decryption methods. Session layer is also adding some control information, so it will be added to this each and every data portion. Next, we are sending this information to the transport layer. So transport layer does more than the things that they have done by the top layers, because transport layer is actually, it's like intermediate layer between the communication systems and the upper layers, right? So upper layers like session, presentation, and applications layers are very closely contacting with the user. The transport layer below the like bottom layers like transport, network, data link, and the physical layers are very closely contacting the system, right? So they are very close to the hardware. So because of this, this transport layer is like the intermediate layer for communication process between the user as well as the communication system. So it plays a very important role in here. So what it says, the message is segmented or broken into pieces for transport. The transport layer adds control information in a header so that it can be assigned to the correct process and all segments put into proper order at the destination. The segment is sent down to the network layer. Now, transport layer will look whether they can transport the data portion that they have received. Now, for an example, if the data portion is too large to send via the transport header, the transport layer, it will be further divided into segments, right? So in here you can see these one single data portion is added with transport header. Right? Now in this data portion, actually what we have is application layer header, right? I will write it as AH, presentation layer header, as well as session layer header. So all of these header informations are actually control informations. They will be known as control information. So as I told you, the application layer will attach the information regarding the application softwares that they are using. This current application is using. For an example, if you send an email, it can be Outlook, right? So like this, the application software that you are going to use, that information remains inside the application header. So application header contains all the control information regarding the application that you are working. And also, if you consider presentation layer will add information, control information like whether we are doing compression, data compression, whether we are using encryption process, or do we have special data formats like audio files, like video files, right? Like this, we have that we have certain information regarding the data presentations, right? Data representation. And session layer is also keeping some information regarding the current session that we are used to do the data transmission, right? So all of these header informations are added to this data, right? For individual set, we are adding all of this information, right? And this data will be added with a transport header. So if the size of this data is too large to handle, it will further break down into portions and take them into separate segments, right? Otherwise, it will handle as one single portion. So as you can see, the transport layer is adding transport header. So what are the things that we do under this transport layer? They will add information about the number of segments that they are handling, right? Because there should be a sequence. Now, when you break the message into a pieces, you should have a proper sequence. Otherwise, when you receive the letter at the end or either the email at the end, right? The receivers should be able to read the correct information, right? So if you are not capable to read the correct information, it will be a problem. So to read the correct information, you should assemble the data packets in the correct order, right? So there should be a sequence or proper sequence order, sequence number. So this information will be handled by the transport header, right? So other than that, we are handling a lot of functionalities via the transport layer, but just for your information, it will be handled one information like sequence, right? The sequence of the data packets. As well as it will notify the communication systems about the application that they are working, right? Now, for an example, if you are working, if you are trying to access a web page, right? Let's say that you are browsing for a web page like Google or either Facebook or whatever the web pages. It will handle as an HTTP protocol request. So HTTP is a protocol, right? HTTP. So it's a protocol. So this protocol is known by the application layer. But for the transport layer, they don't use this protocol name as it is. Instead, they will use number 80 from the transport layer. So transport layer will see this whole protocol as number 80. So using this number 80, they can identify what is the process or what is the application that they are handling. So other than this sequence handling, transport layer will handle the process information, right? So when you add transport header, we give a special name for this unit. Right now you can see this is just one single unit. So this single unit is known as segment. Right, so that is the name given for this transport header plus data. Okay, it's known as segment. So this segment will send towards the next layer. So the next layer is network layer. Network layer will add more information to this data, right? To this segment, right? So this portion, it was the segment, right? Segment was added with the network header. So what's inside this network header? The internetwork or network layer adds IP addressing information in an IP header. The segment is now an addressed packet that can be handled by routers en route to the destination. So what is mean? In here it says this is added with some IP header or network header, right? IP is the protocol name, right? So actually we are adding a network header. So the network header will work according to two protocols. Either you can add IP version 4 protocol, or else you can use IP version 6 protocol, right? So both of these protocols are known as logical addressing information. Right? IP version 4 and IP version 6 protocols are logical addressing information. Okay, logical addresses. So when you are working with data link or when you're working with physical devices, I told you something like physical address, right? So this is logical address. So IP version 4 and IP version 6 addresses are logical addresses. So these things will be embedded to your data packet via the network address. So why do we need that addressing information? When you send a letter, even via the postman, you have to add the receiver's address, right? It's not compulsory to add the sender's address, but at least you should have receiver's address, right? So in here, the data packets, any data will be transferred with the receiver's address and sender's address. So it is compulsory to add sender's IP address and receiver's IP address. So how do we attach this information? That is via the network header. Okay. So network header, usually we call it as IP header, right? We call it as IP header. It's because we are using IP version 4 or IP version 6 protocol, right? So these two are protocols. IP version 4 is a protocol. IP version 6 is a latest version of the IP or internet protocol, right? So when you have this IP header with IP addresses of the senders and the receivers, routers will read this information and it will enroute your data packet to the correct destination. So actually it will not forward your data packet to the exact machine. It will forward your data packet to the network, right? To the corresponding or destination network. Okay. So the whole portion, this segment plus this network header, we call it as packet. Right? Segment actually includes transport header and the data. So when you are adding all of these things together with the network header or either IP header, we call it as a packet. So that's the usual way of calling data transmission, right? We call, like, even you have heard that I might say that data packets will be transferred from this end to the other end. So that's a common way of saying how data will be transferred, right? We call data packet. It's because we use this name packet to refer to whatever the data that we are passing, right? And when you are handling further layers, the next layer, that is the data link layer, comes as the second layer of the OSI model. So you are adding this packet, data packet, to the next layer, right? We will pass this data packet to the next layer. Now we also how we have started, actually it was just a simple email message, right? We were trying to send a simple email message. So when you transfer the email, actually we have to divide it into small portions. The whole email will not be sent as once, right? So you might have just one information saying that whatever the subject, or maybe you will request something from the other person, or maybe kind of attachment, but still you have to divide it into small portions, and then you are adding some control information from application, presentation, and session layers. And then we were adding transport layer data, right? Transport layer control information. And further, we are adding addressing information to this data packet via the network layer. Now, the data packet is addressed. It has a lot of information, but still you have to send it to the next layer, that is data link layer. So from the data link layer, you can see we have frame header as well as there's another header. Actually, this is not header, it's a trailer, right? We call it as trailer, right? This is a trailer. This is called frame trailer. It's the frame trailer. So from the data link layer, it will add more information to this data packet, right? Now, when you consider this portion, this is what we call as the packet, right? This is the packet, okay? So packet was added with the data, transport header, and network header, or IP header. Now, from the data link layer, we added more, a header and a trailer. So when you have frame header and a trailer, we call this whole unit as a frame, right? So this whole unit, including the header and the trailer, is called as frame, right? So what's inside this frame header? You have learned MAC address, right? So when I was teaching NIC, Network Interface Card, I told you we are embedding MAC address of the PC to this NIC card. Right? We are embedding the MAC address to the NIC. NIC used to have the interconnectivity, right? Otherwise, we can't connect our computers to the network, right? We should have NIC to provide internet facilities. So when you are embedding this MAC addresses, I told you that MAC address is again a very unique address. That you can't handle MAC addresses in a wide area network because it will be handled by switches or layer 2 devices, right? So in a local area network, you can use this MAC address to transmit your data packets. So that's what we do with frame header. Inside the frame header, we are going to store MAC address. It's a physical address, right? So we call this as a physical address. It's because it is embedded to a hardware device. But IP version 4 and IP version 6 addresses are not embedded to the device, right? You can assign it, right? You can change it, right? Administrators can change it or assign the new IP address. But MAC address, we can't change it because it is embedded to the hardware component. So this is a physical address. So this information will be stored inside this frame header. So if you are going to communicate within a local area network, it will be helpful to find the destination device. What's inside the trailer then? Inside the trailer, you can find error handling information. Error handling information. So from the data link layer, it does a very unique, very important job, that is error handling, right? So they will receive error-prone data from the physical layer. So it will be taken care by the data link layer and corrected by the data link layer. So we are going to discuss about this error handling process when we do lecture 14, right? So just remember, in the frame trailer, you can find error handling and error handling information, right? Error handling information. So that's what explaining here. The network access or data link layer creates an Ethernet frame with local network physical address called MAC address, information in the header. The frame also contains a trailer with error checking information. So this contains error checking information as the trailer. But in the header part, you will be having physical address, like the MAC address. Okay. So finally, the frame should be converted into a binary format, ones and zeros. So that's conversion. This conversion is ones and zeros. So binary conversion will be handled via physical address. Right? It will be handled via physical address, physical layer, right? So physical layer will see all of this information, like you have sent an email with the content, but physical layer will see all of these information as ones and zeros, as binary values. So because of this reason, the devices that you have categorized into this layer, like hubs and repeaters, they will see these information as binary values, right? So when we were discussing about the networking devices like hubs and repeaters, I told you that hub is not an intelligent device. Why? Hub will do broadcasting. It will not read in the physical address or IP address. It's because they will read all the information as binary values, right? So hubs are physical layer devices, hubs and repeaters are physical layer devices, and they will read information in binary form. So they can't recognize the addressing information, right? So physical layer will convert all of this information into binary format, and further it will convert binary data into signals, right? So you can see this is not a very easy process, right? We simply say that we are sending an email. We just type the content, we just include the recipient address, but behind the scene, it does so many activities to convert this information that you have typed in the email with the attachment into a binary format. And binary format will be converted into an electromagnetic wave in order to transmit via the transmission medium, right? So it's a very complex process. So that's what we explain with the reference model, right? So I told you that reference model will be used to handle the entire communication process. You can learn about the entire communication process. So here we are not focusing for the protocols actually, we will be focusing how we can convert our information into a binary format or signal representation, right? So this process actually known as encapsulation. Right? This is what we call it as encapsulation. Right? When you send your data packet from the application layer towards the physical layer, we call it as encapsulation. Encapsulation. So when you are sending your data packets from the application layer, physical layer, we are adding control information from the application, presentation, session layers, as well as from the transport layer, we are adding header information or control information. From the network layer also, we are adding some control information. From the data link layer, it will add a control information to the header or to the front end as well as to the trailer, right? So that process is known as encapsulation, right? So that's what we are explaining in the slides, right? In the previous slide, this diagram explains with terms, right? So we'll see them as well. If you want to note down, you can note down this information. Okay. So we'll go back and see what are the things explaining here. in the protocol data units and encapsulation section, it says what we are going to do and the process names like encapsulation and decapsulation and special terms like protocol data units, right? When application data is passed down the protocol stack on its way to be transmitted across the network media, various protocols add information to it at each level. So every layer will be added with some information, right? So we are adding some control information, as I told you with the explanation. So when you are adding all of these control informations from each and every layer, we are giving a special name for this unit, right? It's not going to be data for all this. It's not going to call as data packet for every time, right? We give different names. So these naming conventions we called as protocol data units, right? The form that a piece of data takes at any layer is called protocol data unit. General term is packet, right? So that's why I told you we used to call these data portions as packets. The process of adding control information as it passes through the layered model is called encapsulation. So that's what I explained you with the diagram. Decapsulation process means when you receive this data packet, the received information will be first received by the system's physical layer, right? It will be convert back to the binary format because you are receiving a signal. Signal will be converted back to the binary format, and you have to send it towards the data link layer. So data link layer will see the frame information. It will read the frame header and the trail information, and then it will pass the next level, pass it to the next level, that is network layer. So actually it will pass a data packet to the next layer. And from that layer, it will read the IP address information and send it towards the upper layers, right? So that process is known as decapsulation, right? Decapsulation means the process of removing extra information or control information and sending only the original application data up to the destination of application layer, right? So this is this picture shows you how host A and B will be handled. So host A is one of your computer, right? The sender's computer. So inside the sender's computer, you can see all of these 7 layers. And when you are adding more and more control data information into your data portions, we are giving different names. So that's what we call as protocol data units. Each layer adds control information at each step, right? From the application layer, it will add application header. From the presentation layer, it will add presentation header. Likewise, it will add some control information. So these information will be added to your data, but we don't change the protocol data unit name in first 3 layers, right? We call this data or the information that you pass as data, right? The protocol data unit name is data. But when you send it to this transport layer, so there's a power cut. Transport layer is adding transport header, control information from the transport layer as well. But up to this layer, what we call it was data. But when you send it to the next layer, we are added with the transport header, so it will be known as segment. So segment will be forwarded to the next layer, that is network layer. From the network layer, we are adding IP headers or network header. So then we give a new name, that is packet. Packets will be sent to the next layer, that is data link layer. From the data link layer, we know that we are adding header and a trailer, so we call it as frame. Frames will be forwarded to the physical layer, but physical layer will see all of this information in binary format, so we call the protocol data unit in the physical layer, that is bits. So that's what we explained as protocol data units. The generic term for data at each level is protocol data unit, PDU, but a PDU is different at each layer. So we don't call with the common name. We have different names for each and every layer. For example, a PDU at the network layer is different from the PDU at the transport layer. So from the network layer, we call the PDU name as packet, transport layer PDU name as segment. The different names for PDUs at each layer are listed in the figure. So you can see what are the protocol data unit names given for each and every layer in this diagram. So next, we have this explanation for the encapsulation. That's what I explained you recently. And finally, we have this encapsulation and decapsulation diagram. So if you examine this diagram, you can see from the layer 7 towards layer 1, we are sending our data packet. So each and every layer will be adding a header. So layer 7 header, layer 6 header will be added. Layer 5 header will be added in here. Layer 4 header, that is transport layer header added. Layer 3 header or IP header is added. And from the layer 2, it will add in a header and a trailer. And finally, in physical layer, it will be converted into binaries. So adding headers is known as encapsulation. And when you send it to the recipient, now in this picture you can see data will send from this left hand side to the right hand side. So this right hand side host is the recipient or the receiver. So you have to send your data packet towards the application layer. So that process will read the control information from each and every layer and it will be removed. Right? So that process is known as encapsulation. Right? So it's explained in here. The headers and trailers contain control information for the network devices and receiver to ensure proper delivery of data and to ensure that the receiver can properly interpret the data. So we are adding a lot of control information in order to have very smooth communication process. So today we discuss about lecture 12. So that's the ending of the lecture. So I explain you how encapsulation process works. So decapsulation process will not be explained in here, but you can see how it works with this diagram, because from the each and every layer, it will read the corresponding layer headers and the trailers, and it will be removed by the corresponding layer bank. For example, when you send the binary pattern to the layer 2, it will read header and the frame trailer, and it will remove them from this data portion and send the packet to the next layer. Right? So only the layer 3 will receive data and the other control information up to layer 3 network header. So today we discuss about protocol and reference models. You have identified why we are using them, what is the requirement to have protocol layering or layered architecture. And with simple communication process, I explained why we have that requirement. And finally, after the break, we discuss about the encapsulation and the protocol data unit names. So you can read further about this unit. If you read chapter 2 from Fauzan. So you can read chapter 2 network models. So you can get a lot of information regarding this lesson. Right. So that's all for today's lesson. That's the end of today's lecture. So there's a tutorial for this lesson as well. I will upload tutorial 9 to the module. So then you have some time to answer the questions. Actually, there are 4 questions based on these layered network models lesson. ISO SI 7 layers. So you can answer those questions during the vacation time period. Right? So that's all for today's lecture. If you have questions, you can ask. Seems like no questions. Okay. So we'll wind up the session. Thank you for participating in this online session.